In this video, we're going to continue our conversation on normalization. I'll be a little bit repetitive, but it usually takes some people a bit of time and a bit of repetition to sort of come to terms with this process. So, in the normalization approach, we imagine that we are presented with some data, maybe some big, large table of data, and then we are looking to sort of uh, break it down into sort of smaller units, smaller tables, and get rid of any redundancy that we might find in the report or the table or whatever it was that was presented to us. And we don't want to lose any information. We don't want to lose, especially the relationships, but we want to get rid of any unnecessary repetition. And so there is a sort of a set of procedures known as the normal forms, which help one go through this process. And once you sort of learn the process, then you don't care so much about the steps as the end product, but but it does help to sort of go through a formal process to make sure you don't miss anything and just to sort of develop some ideas of like what tables should look like in a relational database. So the first thing is, and we've said this before, that we don't like any multi-valued fields. So sort of before we had database management systems, we just sort of each individual, like, I don't know, corporation or entity, business entity would, generate their own uh, system, and it would be file based, and then your code would have to sort of read files and parse them. And we wanted the database management system to take over that to so that we didn't have to parse. But if we have a multi-valued field in our database, then we're sort of reintroducing some parsing. We're sort of going somewhat back to the sort of file-based approach. And so the first thing we do to reach what's called the first normal form is to eliminate any multi-valued fields. We don't want any, if a table is rows and rows and columns intersect at a cell, I don't want any cells with a list of things with, a whole, I want it to be one individual little thing in each cell. So here I have some imagined table where I say that PA is the state Pennsylvania spelled out, its capital is Harrisburg, and then there are some people in my database associated with that. And then under that, I have same for New Jersey. But so you can see within the last names and the first names, I have some multi-valued fields, that there is some kind of list of last names, some list of first names. And we don't want that. So then we flatten the field. We take the information, the repeated information, and or the list information, and make each part of the list its own row, and the sort of the other parts then become uh, duplicated, replicated. They're sort of so you see there PA, Pennsylvania, Harrisburg over and over again. So this, our overall process is to get rid of redundancy, but the flattening of the file actually brings in redundancy. And a lot of the next steps in normalization have to do with primary keys to sort of identify fields or sets of fields that uniquely identify a record. And I just want to say that that is sort of easy to state the definition, but not always easy to come up with them. And you want it to be sort of, I don't know, minimal, that you want to only have, you want to be able to identify each record, each row uniquely, but you only want as many fields as you need. So you don't want extra fields in your primary key. And so that balancing act of making sure every record is identified uniquely by the primary key, but not having anything extra in it, um, can get a little tricky sometimes. Okay. One thing I want to say is if you flatten the field, so it's good to have some like rules of thumb to follow. And one is if you just flatten the field, then one of those things that was multi-valued must be either the primary key or part of a composite primary key. So let's take this example. We'll go back to the example that we just looked at in a minute, but here's some like transcript data. So I have some student, Mary Margaret, who's taken a number of courses, and uh, John James, who's also taken a number of courses. And so then I flatten the field, and so I repeat Mary Margaret many times. I repeat John James many times. And do I have that? No, I don't have that yet. But the course information is going to have to be part of the key. So I can, when I make this sort of one record of Mary Margaret with multi-valued fields, when I make it into separate rows, then to distinguish the philosophy 151 row from the math row, math 150 row, I'm going to have course information in there. But it's not going to be, that's not going to be enough because it's possible that Mary Margaret and John James took the same course. And so then I will also need student information. So I'll probably need something to identify the course, maybe department and course number, and then also something to identify the student. Um, and then if the student can retake the course and get a different grade, then we might also need semester. So this is after flattening, we will certainly need a composite key. And the course, the repeated thing, in this case, the courses and the grades, there will something in there must be part of the primary key. Or it could be the primary key, but it's either the primary key or part of the primary key. In this example, it's part of the primary key. If we go back to this people representing a state and the state capital and so on, then the repeated thing are these names. Um, and then if I take the first name and last name as unique, or if I introduce some person ID, then that, just the person by itself will be enough. So that might be the combination of first name and last name, or I might introduce some person ID, but I don't necessarily need any of the when I take the multi-valued stuff, and I pick out what I need in that to be part of the primary key, that will be enough in this case because I can look up the person and say, oh, that person represents PA. So in the student case, I need something from the repeated stuff, from the multi-valued stuff. I need something from the course and more. Whereas in this case, I need something from the repeated things to identify the person, and I don't need more. Okay. But so what did, again, we are introducing a bunch of redundancy here, and our overall goal is going to be to get rid of redundancy, but we're introducing it here. But again, we're going back to the problems why we introduced uh, database management systems in the first place over file processing was that we don't want to be responsible for parsing things and breaking them down. And so this is going to help with searching. So the name, I might be looking for a name. Is this person anywhere in my database? Is this name appear anywhere in my database? I don't want to be responsible for parsing within a field. So that's why I want the flattened table. So then I don't have multi-valued fields. I don't have to parse anything within. What I'm looking at will be sort of an atomic, single valued thing that I can easily look up. Now, in the 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 idea of being atomic comes up later on in database. So here I'm just thinking atomic in terms of purpose of searching. I want the things that I might search to be uh, simple whole cells. Um, but we'll start talking about in another time sort of transactions, things I might want to do with a database. And I might say that like two transactions need to sort of become work as a unit. If I have a database representing somebody's bank account and I'm going to take money out of one account and transfer it to another account, then those two transactions must be some kind of form some kind of unit. They must happen together or not at all. And that's another term, another time when we will see the term atomic come up. And it's just a definition of parsing. So we don't want to have to parse. That's the idea of flattening the file. So I don't want to have to break the thing up into parts. So in speaking, parsing is breaking, understanding phonemes, sort of sounds that are within a language and words within a language and so on. In computing, it's sort of breaking data down into some kind of components. We don't want to have to do that in our database, or we don't want as database administrators to have to do anything with parsing. We want the database management system to take care of it. So we want to enter the data in such a way that we won't have to parse, that any parsing will be handled by the database management system. Okay. But the flattening introduces redundancy. And some repetition is not redundancy. Some repetition is needed to establish a relationship. But then there are parts of where repetition is unnecessary and causes a problem, especially like an integrity issue. So this was always my example because it's happened to me. Um, you move, and so you go to your organization and you say, here's my new address. And you sort of expect, if the database is proper and they've gotten rid of all the redundancy, that if the address is changed in one place, then that should sort of follow everywhere, all my data, and if you try to connect it back to an address, will have the new address. But you find copies of the address that are not. There's often redundancy in systems, people not working with a centralized, properly organized database. Okay. So here in this, back to this example of people associated, representing or associated with a state, we're going to say that we're going to keep, uh, say, PA, pick one of the things, but so I'll pick the simpler thing, the PA. I'm going to sort of say that is not that's a sort of more necessary repetition to establish the relationship between the person and the state that they're representing. But then the name spelled out of the state and the capital of the state, that's uh, not necessary. So some repetition necessary to establish relationships, other repetition not necessary, and so should be filtered out. Okay. And then the way that we're going to do this is that we say that if we know the reason we can pull out Pennsylvania and Harrisburg is that if knowing PA is enough, and PA will give us, if we see PA, then it can give us Pennsylvania and it can give us Harrisburg. And so that is, we have this concept of functional dependence, that one thing determines another. So we're almost back to the idea of a primary key of uniquely identifying something, but it's not an entire row, but it's like some subset of things. So the state symbol will uniquely determine the state name and the state capital. So we can say that the state name and the state capital are functionally dependent on the state symbol. Okay. And again, back to our idea of like back to the flattening idea. Um, If I have a song that is a duet, then and I have something that identifies the song, I've given the song some ID, um, that's not going to be enough to identify a person. So if the song is a duet, Lady Gaga and Bruno Mars singing "Die with a Smile," then identifying this song is not going to uniquely give me the artist. So, because I want one artist, I don't want in my database, I don't want uh, a multi-valued field of Lady Gaga and Bruno Mars. I want them both in their separate rows so I can find, if I search for Lady Gaga, I will find it. If I search for Bruno Mars, I will find it. And so it's not, the song is, does not, the artist here is not uh, functionally dependent on the song because of the multi-valued stuff. So again, this idea of uniqueness is important. Same in the primary key kind of idea. It's also important in the functional dependence idea. But when you do have a functional dependence, when you do have something like PA uniquely giving us Pennsylvania, or PA uniquely giving us Harrisburg, then that kind of dependency, functional dependence, is the key. Seeing those, recognizing those within your data, that is the key to getting rid of our redundancy, our unnecessary repetition versus our necessary repetition, which maintains our relationships. And so then we just have these various levels of normal forms, and then we will introduce some confusion at some point, or not confusion, but a sort of a better process along the way, where we are not going to talk just about a lot. We're going to start off a lot with primary keys, but then we're going to sort of extend some of the ideas to what are called candidate keys. And um, so that will sort of mix up some of these levels. Sort of, are you talking second normal form versus what we call a generalized second normal form? So we're going to have these levels, and then doesn't matter whether you, uh, in the long run, whether you strictly stick to these levels as a second normal form or as a generalized second normal form. What matters in the end is that you get rid of the redundancy, and you can still have all the relationships, that you can still get back to sort of where you came from. Okay. And but in these, as we go through this process, the distinction between second normal form, third normal form is the type of. So we're going to sort of make distinctions within types of functional dependence. And so we're going to say, like, oh, so here's something that's functionally dependent, and here's the type of functional dependence, and that will tell us sort of, when do we decompose, what level, how far are we going in our normalization process. And just the terminology functional dependence is sometimes, I don't know, sort of like passive. You talk about something being functionally dependent on the second thing being functionally dependent on the first thing. But to sometimes, to make it a little more active, we can sort of turn it around, and then we use the term determinate. So if I can say, if I previously was saying B is functionally dependent on A, then I can turn it around and say A is determinant of B. So just a way of turning the sentence around, just to prevent some sort of awkward passive voice type things. Okay. And so if we were previously saying that the state name is functionally dependent, depends on the state symbol, we can turn it around and say the state symbol is determinant of the state name. Okay. And again, if attribute A is functionally dependent on attribute B, that means that if I know A, I can tell you B uniquely. And it can be just a looking it up thing. It doesn't necessarily mean like I can calculate it in some way. It just means it can be looked up. Um, the determinant attribute A may be composite, may have more than one field, more than one column, more than one property or attribute, whatever you want to call them. It may have more than one of these things. And so as we start talking about types of functional dependence, uh, one of the types or distinctions we make is whether it's fully dependent or partially dependent. So we're imagining A to be a primary key. So a primary key is going to be determinant of like everything else in the record. But now we look at a given field that it is that the primary key is determinant of, and we can ask the question whether it's depends on the full A with all its parts, or whether it's partially dependent, whether it only depends on part of A. And again, assuming that A is composite. If A is single, if A is just a single attribute, uh, then there are no partials. But if A is composite, if it has a number of fields, then that gives the possibility of some partial dependence. Um, One thing to note, like especially my example with like the state symbol and the state name and the state capital, uh, that example sort of I could have chosen any of the three. We tend to choose the simpler thing like the symbol, but I could have said like, oh, this the state name gives me the symbol, but that's not always the case. These functional dependencies are not always a two-way street. So I can say that the date of birth is functionally dependent on social security number, because if I know the social security number, I can then look up the person and then find their date of birth. But it doesn't go the other way around. I can't say that uh, the social security number is not functionally dependent on the date of birth. If I know somebody's date of birth, well, a number of people were born on that date, and they don't all have the same social security number. So it doesn't always go both ways. Some things do, but some things don't. Now we're getting ready to sort of talk about transitive dependence. And this will be important as we start talking about the third normal form. And this is saying, and we're borrowing this concept from math. We borrow lots of concepts from math, of the concept of transitivity. And so that if B is functionally dependent on A and C is functionally dependent on B, sorry. So let me just say it again. If B is functionally dependent on A, so A gives you B. And if C is functionally dependent on B, so B then gives you C, then we can say that C is transitively dependent on A. So A gives you B, then gives you C, so A can give you C. So if I know A, then I can determine C again uniquely. So if I have an employee number, so I've assigned my employees and numbers, and that can be functionally dependent on the social security number. And then the salary is dependent on the employee number. So if I know the social security number, I can look up their employee number. And if I know their employee number, I can look up their salary. So then we can say that the salary is transitively, functionally dependent on the social security number or the social, or we can turn it around and talk about determinant. The social security number is determinant of the employee number, and the employee number is determinant of the salary. Therefore, the social security number is determinant of the salary. But again, not the other way around. Um, Two people might have the same salary. So knowing their salary does not determine their employee numbers or their social security numbers. Okay. So just one more example of some transitive. Imagine you have a table and you're going to, sell some stocks, some kind of transaction with stocks. So then, of course, it's going to have a stock ID. What stock were we trading in this transaction? And so let's say that the whole transaction was given a transaction ID. And then, so if I know the transaction ID, I can look up the stock ID, what stock was being traded. And then from the stock ID, I can look up the sort of more spelled out name. So then the the transaction ID is determinant of the stock ID, and the stock ID is determinant of the stock name. So this is a transitive dependence. So the transaction ID will be determinant of the stock name. And we're going to use these sort of partials and the transitives, and then some concept of uh, primary key and candidate keys to do our various normal forms. So in a discussion to come later. Thanks for your attention.